All right, welcome. My name is Kelly Van Oppen, and I am a teaching naturalist at the Montana Natural History Center in Missoula. With me, I've got my co-host, Bailey Zook, who is in the background. Her job today will be helping you guys through questions or comments that you have. You can go ahead and enter those in the chat or in the Q&A. The chat should be at the bottom of your screen. If you haven't already opened it, there might be a little orange box that says chat. You can go ahead and open that up. When you write in the chat box, it only shows up on Bailey and my end. So other participants can't see what you're writing. So feel free to ask her questions if you're wondering what's going on. Q&A is up usually in the top portion of your screen. You can also ask her questions there. So we'll go ahead and get started because it's 10:30. Let's start with having you guys get acquainted with that chat box. You can go ahead and open it up. And if you wouldn't mind just writing in where you're tuning in from. We like to get a idea of where folks are tuning in from. So if you could go ahead and write where you're tuning in from in the chat box, that would be fantastic. See Missoula. Anywhere else besides Missoula? It looks like it's pretty much Missoula right now, unless we've got anybody out east. South Hills, some more Missoulians, welcome. Wonderful. Well, we'll go ahead and get started. And again, that chat box will be, if you have any questions or want to share anything that's related to the topic, you can go ahead and write it in there. So we're going to start by watching a portion of this video. I'm not going to have the sound on because the sound really isn't the important part of the video. What I want you to do is just kind of pay attention to what's going on or what you think is going on. And then we're going to share some of those thoughts in the chat box in just a minute. I'm going to go ahead and pause it there. So now I'm wondering if you wouldn't mind sharing in the chat box maybe a few words for like observations that you made while watching that video. If you want to share anything you wonder about, maybe you wonder what it is or what it's supposed to be doing, what it's made out of, go ahead and write down any observations that you had in the chat box. Maybe what you think it was. I see that the sand shifts colors. That's a really great observation. If you have an idea of why the sand might have changed colors, you can go ahead and enter that. If you have any maybe statements as to why you think the sand was changing colors. Sand and a projector. Yes, the projector is a really important piece. So you probably noticed that the projector was most likely above the person building those landforms in that box. Yep, making mountains, definitely. So lots of different landforms. They were making mountains, and then they were also making valleys. They were making it rain, right? And so there was precipitation that kind of went down the mountains and into the valleys and created rivers and lakes and other landforms. Awesome noticings. So this is what we're going to be focusing on today. We're taking the idea of these three-dimensional landforms, and in other words, three-dimensional being things that you can walk around, things that you can see from multiple sides and angles. How do we take a three-dimensional landform like a mountain or a butte or a mesa And how do we take all of that information about that mountain or landform, the elevation, if there's any special features on that, if the elevation changes, how do we take all of that information and put it on a flat, two-dimensional piece of paper? That's what we're going to be looking at today. In other words, how do we turn something like this, so much going on, so many different peaks and valleys and lakes, how do we take something this complex and turn it into this, something flat, just basically a map? How do we do that? So today we are going to be cartographers, and we are going to make something called a topographic map. Now those two words in blue might be brand new words to you. That's awesome. That means we have something to learn today. We are going to do a little investigation with the words cartography and topography to figure out what they mean. So I'm going to launch a couple polls here in a second, and a poll is kind of like a multiple choice quiz. Not going to be graded on it, of course, but I want you to try to figure out if we can figure out together what these big words mean. Oftentimes words like this, we can dissect into smaller words and figure out their roots. In other words, where they came from and where they originated from. We will start with carto. So the first portion of this is carto. If you have an idea about what you think is the origin of this word, I'm gonna launch a poll right now, and I'm gonna have you vote. So do you think carto comes from a Latin word for chart, a Greek word for mountain, or a Latin word for shape? Again, we're not grading this. Just go ahead and take your best guess. We've got 2 people, 3 people, 4 people. 33% of us has voted. We're at 50%. It'd be awesome if we could get 100% of viewers to vote. We're almost there. Let's put about 20 more seconds on the board. 92% of you have voted. About 10 more seconds, then I'm going to end the poll. All right, so I'm going to end the poll now. It looks like we're really split here. I'll share the results with you. So it looks like the 50% of you are thinking it means shape. Some of you voted for the chart. It does sound a little bit like chart, or mountain. Awesome. So it's kind of all across the board here. So now we're going to do the second portion of this word, graphy. So I'm going to launch a new poll with some new, let's see, polling, with some new choices. So here it comes. Where do you think the word graphy comes from? Got 3 choices up on the board. Usually Greek or Latin, which is interesting. All right, votes are rolling in. 20% of us have voted. And if you're just joining us, welcome. We've got a chat box going on in the bottom right. So if you need help catching up, right now we're just voting. There should be a poll in the middle of your screen. We're just trying to figure out what this word cartography means, because it's going to be a big word in today's presentation. All right, I'm going to close up the vote here. 100% of us have voted. Nice job. Again, we're kind of all spread out in our thinking. I'll share the results here on your screen. So a lot of us are thinking picture, that would make sense. Some of us are thinking Greek word for drawing or writing, or maybe just knowledge. Awesome. So, cartography, this big word, what is in this word? Carto is from the Latin root charta, which means chart. And graphy is from the Greek word graphia, and this means to write or to draw. So if we take those 2 little pieces of the words, carto and graphy, put them back together again, we get cartographer. So this is someone who quite literally writes or draws on a chart. So back in the day when they were making maps, a lot of people referred to them as charts rather than maps. So that starts to make a little more sense why we use the word chart instead of, say, map. Here's our next word, topography. Now we'll dissect this word into 2 pieces, topo being our first. So topo is our first one, and I'm going to launch poll number 3 here. Again, Greek or Latin choices here. So it should be showing up on your screen. Where do you think the word topo comes from? You guys are getting really quick with the voting. That's awesome. 40% of you have voted. All right, 73%. About 20 more seconds. See if we can collect any more votes here. And if you're just joining us, we're just launching a poll here to try to figure out where the word topography comes from. So if you want to jump in, that would be great. We've got 93% of people who have voted. Maybe 5 more seconds to get the last minute ones in here. All right, we're going to end poll. Share results here. Looks like a lot of people are voting for the Latin word for mountain. Some people are thinking to draw, and quite a few of you are thinking it means place. Awesome. I'm going to stop sharing here. And now this last word, graphy, it should be a review at this point, but I'm going to launch a poll just to see if I can get any of you. Let's see how well you're paying attention in that first quiz here. So graphy, what is graphy? You guys are super quick with this one. It means you are got on it today. 56%, 81%. Almost there. Let's see if we can get 100% of us to vote. Climbing, climbing. About 10 more seconds. And if you've just joined us, welcome. We are just finishing up a poll here, trying to figure out what this big word means. 93% of us, and I'm going to close down in 5 seconds here. All right, share results. Most of you, 93% of you, remembered that graphy comes from that Greek word to write or to draw. Nicely done. So dissecting this word, topo actually is a Greek word, topos, which means place, and graphy again, graphia meaning writing or drawing. So literally topography is writing or drawing about a place. So a specific kind of map making. Now what's in a map? Maps can tell us all sorts of things. This is obviously a map of Montana. It is not a topographical map. Instead, this is a map that shares boundaries, cities, or counties within a place. So this is one type of map, but not a topo map. Here's another type of map. Again, not a topographical map. This is just a hydrological map. So it just shows us water like lakes or rivers. Still not a topo map. Here's yet another map, not a topo map. This map instead looks like the place that it's representing. And in this case, a ski hill. So it's showing us runs, it's showing us things that are important for when we go to this place to go skiing, but still not a topographical map. So topo maps are a little bit different because they take an image like this. Remember the video was the projector above, kind of a bird's eye view of a landscape with all the mountains, rivers, landforms, and even some man-made features. And a topographical map takes an image like this satellite image and uses something called contour lines. So here's a map of that exact place that that satellite image was showing us. And instead of the satellite image with the trees and the rivers and all of that, instead they use contour lines. And we're going to talk more about what these contour lines can tell us about the landscape. So now what is in a line? So on the top portion of what you see on your screen, these little bright lines here are all contour lines. They all show different levels or different elevations, how high or how low a landform is. So this is what you see on your map. Now down below what you see on your map is what you would see, let's say, from a parking lot, or if you're walking alongside this mountain. This is how we're used to seeing the landform. So it's more three-dimensional in view. But you can see where those colored rings would match up on your map. So with a topographical map, you have to get used to seeing it kind of from a bird's eye view versus how we're used to seeing it, which is from our human view of just being able to see that landform kind of out in front of us. So here's another exercise we'll do to try to figure out more about contour lines. On the top, we have a landform. So this would be what it would look like on your topographical map. And I'm going to pull out this dark purple contour line first. On this map, the dark purple line is at 500 feet. So what we can do is pull down that same color and put it on our graph at 500 feet. And in just a minute, you'll see why I'm trying to graph this, because it's going to give us a clearer image of what this actual landform looks like. So now we're going to the outside. The outside ring, the orange ring, is at 400 feet. So this contour line is at 400 feet. And it's hard to tell, but I did pull down to match up that 400 foot line all the way down to the graph on the bottom. So now we have a 500 foot line and a 400 foot line. And here comes a little bit of a math problem for you that we're going to do in the form of another poll. There are 4 lines that live between the 400 mark and the 500 mark. So there are 4 lines. I see a yellow one, a bright green one, a teal one, and a dark blue one. My question is this: if we have 400 at the orange level and 500 at the purple level, what is the elevation for each one of these lines that live in between the 400 and 500? They're generally in equal amounts, so you might have to do a little bit of math here. I'm going to launch our next poll. You're going to have to do a little bit of math to figure out what the values of the 4 rings in between the 400 and 500 are. So I'll give you a little bit more time so you can do the math. Got votes rolling in already. Almost half of you have voted. We got some mathematicians in here. Maybe about 20 more seconds. %87 of you have voted. Nicely done. Bet nobody wanted to do math this early in the morning. All right, about 5 more seconds. Fantastic. All right, I'm going to share the results here. So 80% of you voted for the values of 420 feet, 440, 460, 480. So thinking about that pattern of what would have to happen in between 400 and 500 to make them equal amounts. We have some votes for that middle choice and some votes for the top choice. This was kind of tough. And again, you probably weren't expecting to do math this morning, but math is an important piece of mapping. So in reality, the amount of space between the contour lines was exactly the 420, 440, 460, 480. And we call the amount of space in between the contour lines the contour interval. So here's your next question. With our contour interval on this map, what do you think the contour interval was? So if the answer was 400, 420, 440, 460, 480, 500, what is that number climbing by? There should be a poll that's in the middle of your screen where you can vote now. And this is the last math question. All right, about 10 more seconds. Quick now. About 5 more seconds. All right, well done. Most of you said 20 feet for the contour interval. In other words, each line was growing by 20 feet. You are correct. 20 feet is the contour interval for this particular map. Now, not every map is going to have a contour interval of 20 feet. You can find the contour interval on your map, on the specific map you're looking at, in the key. So what we're going to do now that we know that our contour interval is 20 feet, we're going to start pulling down the colored circles or the contour lines, and we're going to bring those down to their matching point on the graph. And something really cool is going to happen once we get all the values accounted for. It's just the yellow there. So now what we can do is we can draw the side profile of this actual landform. So again, kind of review here. The topo map is kind of how a bird would see it, right from above, just like the projector in the video. And the bottom portion of this is what the actual landform would look like in real life. So here's another exercise we'll do. We've got a satellite image, and what we're going to do is we're going to slowly lighten the satellite image, and our hope is that the contour lines underneath on that topo map match up exactly. And they do. And it's not magic. This is the beauty of cartography, especially the beauty of a topographical map. One last example here, and I'm going to ask you to reply in the chat box in just a minute with your answer, is looking at this place, Devil's Tower. So we have the real Devil's Tower, the picture on the right, and we have the map of Devil's Tower on the left. So my question is this. We see topo lines, of course, on this topographical map, but what do you notice about the topo lines the further up you move on Devil's Tower? What starts to happen with those contour lines on Devil's Tower? Do you notice anything happening with the contour lines on Devil's Tower? If you do, you can go ahead and write what you think is happening on the map in the chat box. I see people saying the contour lines seem to get closer together. Absolutely. They're getting much closer as you move up Devil's Tower. They get really, really tight, right? Those rings get really, really tight, pinched together. Exactly. So in a topographical map, when our contour lines are really, really close together, it means the landform is very, very steep. So on Devil's Tower, you can see, and it said, somebody saw this as well, they get further apart or wider the further down you go, like once you're into the parking lot or where the trees are, it's really spread out. But Devil's Tower itself, those lines are really stacked closely together. And that's because the landform is very, very steep. Now, this is what's really cool about topo maps, is you can print out a topo map of a place that you've never ever been before. But looking at it and looking at how the rings are arranged, you know what the landform is going to be like. So in other words, as a naturalist, you know what tools you'll have to bring if you're planning on hiking around in this area. With Devil's Tower, you're probably not just going to be able to hike straight up it, right? You're going to need some special equipment to be able to get up those really steep parts. So in just a minute, I'm going to send you off on your way to make your own landform out of Play-Doh or clay. And this video will walk you through step by step how to take a landform that you've created and then turn it into a topographical map complete with contour lines. So this is what the video thumbnail will look like when you go off on your way to make your own maps. But right now, I want to tell you about another cool place that you're invited to go. If you join us next week for part 2 in Adventures in Map Making, you can download your very own topo map. You can download a topo map of a place that you'd really like to visit someday, or maybe a place that you've already visited, like your own backyard, a place that you love. And if you bring that topo map with you, we're going to do something really special with it. If you're not going to join us, that's fine, but you are still welcome to go to these 2 places that Bailey is going to put in the chat box for you. So she's got the list here for you. These are some great places to go and download free topographical maps. So if you want to further your knowledge and maybe go for a hike and take these out with you, get to know a place that you love already or a place that you'd like to visit, here's some places that you can go to download your maps. And I'm gonna just touch bases with Bailey right now. Bailey, did we have any questions or comments that need to be addressed from the previous information, or are we good to go? Good to go, awesome. So our last thing to say here is once you go and build your your landform and make a map. It would be really cool if you shared your creations on Facebook or Instagram, and just be sure to tag us, the Montana Natural History Center, in those posts. We'd love to see what you guys come up with. I'm gonna have Bailey also include, it looks like she's included it once. She's continuing to add that link. So that's the Plateau Mountain instructional video that I referenced earlier on. That will be super helpful in figuring out how to actually build your mountain and turn it into a map. And again, we have part 2 in Adventures in Map Making at the same time next Tuesday, in the same place. So we'd love to have you back for round 2, where you'll learn a little bit more about topographical maps. Thank you all so much for joining us, and I hope you go and make your own mountain and make your own map and share it with us. Keep on wondering. Bye-bye.